So today we're going to find out how we can find the area of a figure that is composed of other shapes. So we're going to use other shapes to figure out area of a larger shape, or at least a different sized shape. So make sure you have your I can statement and today's date at the top of the page, and we're ready to go on. 4 different drawings here. Which of these 4 do you think would be the best for us to figure out the area with it? Yeah, I think of all of these, I think C is definitely the worst one of them because you've got overlapping here, you got gaps, that makes it hard to figure out. The other ones I think you could figure out the area without too many problems. I think A is a little difficult because you've got some very small pieces here to work with to try and figure out how they would fit with another shape. You've got B that's got one size square and then another size square, and those squares do appear to be equal, and it does appear that it looks like maybe 4 of those make up one of the larger ones, but then it's getting to where you're having 2 different units. I think D is probably your best bet to figure out the area on this because all the squares are the same, and these ones that are right here along this angle should be able to be used to find the area pretty easily. Earlier when I was talking about finding spaces, if I take these and kind of like I was talking about before, we can see that, yeah, one of those triangles is half of the square. So we could say each of these triangles are, yeah, 1/2 square unit. Okay. We could use these triangles in a lot of different ways to help us figure out how large a particular space is. See, if I put these 2 together like this, does this still have the same area as this triangle? Yeah, they do actually, because 1/2 of these makes up 1/2 of the square. 2 of these makes the square. We've just got these in a different way. What about these large green triangles? Could we use these smaller triangles to help us figure out the area? Yeah, what do you think about the area for this? How many of these triangles do you think it would take? Okay. Well, it would actually take 4 of these triangles to fit in this space. So if we have 4 of the triangles, knowing what we know about the triangles, what is the area of one of the large triangles? Yeah, if you said that it is 2 square units, you're on the exact right track. And the reason we can make that true is because we know that each of those triangles makes up that same space, and that 2 of these together make 1 square unit. Let's get some information down here. So first definition we need to write down is area. You don't have to write down every single of this. You need to put it in your own words. So the area of a 2-dimensional region measured in square units is the number of unit squares that cover the region without gaps or overlaps. I think you could pretty much summarize this as area is measured in square units in a given area or given region. Okay. We can see that in A we have 8 square centimeters because if we look, we have 8 of these, and they're telling us that one side of this is 1 square centimeter. So that means that B, if B is just that blue triangle piece there, that shaded piece, then that part B is actually also 1/2 of a square centimeter. How do we know that? Well, if it's got the same length and width, and if we could take and put 2 of those into the same square, then that means that it's 1/2 square centimeters. Another term we're going to use is rearrange. So this is just moving those things around, and that's what we were talking about in our previous part here, is that, you know, if I take this triangle and I take 2 of them, and I take the one like this, and then I make a flip so it reflects and fills in that space, so we can know that we actually have 1/2 square units because, or 1/2 square centimeters, because it's able to be rearranged to help us fill in that particular space. And then we have two opposite terms that we need to talk about here is compose and decompose. Now, when we're talking about in math, this can be for a lot of things. We can decompose and compose numbers all the time in all kinds of different ways. But when we're talking about in this particular situation, we're talking about compose, put together, decompose, take apart. So when we were talking about back on our original with our green triangles, that those green triangles, or the blue triangles that we were using earlier, could be put together to make one yellow square unit, or we could take 4 of these, and by moving them around and rearranging them, we could compose the same triangular space, but now we can also understand that it is worth 2 square units in the same way as using 2 of these would make 1 square, because we're able to rearrange those and compose this other shape and use that to transfer that knowledge into being able to figure out our other triangle here as well. So 2 big ideas here. If you've got 2 figures that can be placed on top of one another so they match exactly, then they have the same area, right? The other thing is that if you can use those other smaller parts and you can put enough of those together without overlapping, then those sums of those parts can compose that larger shape and tell you how many units it is. By the same token, you can decompose and take apart a shape to figure out the area by figuring out what the area of one of those pieces is. We can even rearrange the pieces and see that the overall area doesn't change. Okay. See, we can even think about this. This is kind of the green triangle we did earlier, right? We had the 4 pieces. You could arrange those a few different ways. Those 4 pieces taken apart could end up making 2 square units. So by using those, that helped us to figure out the area of that one particular piece. Thanks to my extra great assistant on the screen there. I hope you've been able to see how these work out. So let's do some practice with these and make sure that you've got those definitions, and if you need to go back on something, you've got that down. Otherwise, we're all set.